So I was doing this exercise and I realized I made an important mistake at the 15th minute mark. That hurt a bit, but that's how you learn. So for 19, show that 0, 0 is always an unstable critical point of the linear system. X prime is equal to mu x plus y, and y prime is equal to negative x plus y, where mu is a real constant and is not equal to negative 1. When is 0, 0 an unstable saddle point? When is 0, 0 an unstable spiral point? And I think to do this one, it would be useful to keep in mind this picture right here. So I'm going to copy it, and I'm going to bring it down here. Paste. There it is. So this picture basically has, this works for a 2 by 2. The trace is the sum of the diagonal entries. Actually, I don't know if it works for higher matrices as well. I haven't tried. And this is the discriminant. Sorry, not the discriminant, the determinant. So what we're going to do now is we're going to rewrite this system in matrix form. So that's going to be x prime, y prime. Here we're going to have our matrix brackets. And this is equal to what? It's equal to mu and 1, and minus 1 and 1, all multiplied by the vector x, y, right here. And now, what I want to do is I want to make sure. So if they're saying I want this to be always unstable, how do I make this always unstable? Well, as long as the trace, the tau here, is negative, then I'm good to go. And what is the trace? Well, the trace is the sum of the diagonal components. So my trace, I'll color code it for you. Color coded in orange. My trace is equal to mu plus 1. And I want my trace to be greater than 0, because that's going to make my system at 0, 0 unstable. So let me solve this inequality. In order, I can subtract 1 to both sides of this, and what I get is mu is greater than negative 1. So as long as mu is greater than negative 1, then we're going to be unstable. Now, when is it an unstable spiral point, and when is it an unstable saddle point? So an unstable spiral point, as you see over here, we need to have the trace squared minus 4 times the determinant less than 0. So we already found the trace. Let's find the determinant real quick. I'll do that in yellow. The determinant is going to be mu times 1 minus 1 times negative 1. The product of these minus the product of these. Okay, so what are we going to get? Mu plus 1. Okay, so let's answer the saddle, because we know that as long as delta is less than 0, then we're in the saddle world. So let's put that condition in, and let's see what we get out for mu. We have that this needs to be less than 0, which means that mu needs to be less than negative 1. So if mu is less than negative 1, we're going to get a saddle. Now, that contradicts with this one, which says if mu is greater than 1, then we're probably going to be in this realm right here. But if we want a spiral, then what we want is what I circled in green before, t squared minus 4 delta less than 0. So let's say that t, so this will give us a saddle. T squared minus 4 delta needs to be less than 0. So t squared is going to be mu plus 1 squared minus 4 times our determinant, which is mu plus 1, should be less than 0. So I guess we can what can we do here? Well, we could factor out an m plus 1, and we get mu plus 1 times mu plus 1 minus 4 is less than 0. So we get that mu plus 1 times mu minus 3 is less than 0. So how can this happen? Well, if this is less than what? Less than negative 3, then this is going to be surely negative, and this will also be negative. So that's not good. So we need and anything other than that, like more negative than negative 3, that's going to happen. So, but what about negative 2? Well, if I have negative 2 here, then this is going to be negative, and this is also going to be negative. So that's not good. What about negative 1? Well, here we're going to get negative 4. And here we're going to get 0, so no, we don't want that. Well, what about greater than negative 1? Well, if this is greater than negative 1, then this is still going to be negative because it's 2 negative added together, well, assuming it's less than 0. But this one, if it's between negative 1 and 0, then this was going to be positive, so we're going to get a negative value. So we know that mu here, for this to be true, has to be greater than negative 1. So let me write it on this side. Greater than negative 1. Now, one problem, though, is that we said earlier that this cannot be negative 3. Is there an upper bound? Well, let's see. If this is greater than 3, then this is going to be positive, and this is going to be positive. We don't want that. We want it to stay negative. So we need this to be negative by having it less than 3, and this to be positive. And this will stay positive until we reach less than negative 1. So in substance, we need mu to be between negative 1 and positive 3. And this will give us what? This will give us an unstable spiral Okay, so we'll see in part B with calcplot if we did things correctly. Okay, I will see you there.